Welcome to another lecture for rational functions. So for this lecture, we will discuss vertical asymptotes, horizontal asymptotes, and removable discontinuities of your rational function. Okay, so to start, we will define what is an asymptote. Okay, so an asymptote is a line wherein the graph of a function approaches but never reaches. So in this case, the graph of the curve will just get closer and closer to the line but will never meet it at any infinite distance. We can see here this illustration here in the right side. We have two curves for our rational function. Now, let's try to describe what's happening here. Now, we can see here in this part of the curve, the graph or the curve tries to approach as near as possible with the x-axis. Okay, so the x-axis will serve as our asymptote here. Now, you can see here that as the curve tries to approach the value or the line y equals to 0, which is your x-axis, the curve just continues to extend up to the negative infinity for your x values. So what happens here, the curve will just continue to go nearer and nearer to your asymptote, but it will never meet at any particular point. Okay, so there are two types of asymptotes that you can find in a rational function. So basically, you have a vertical asymptote and a horizontal asymptote. Now we can see here in this illustration, so the red line represents your vertical asymptote and your green line represents your horizontal asymptote. Now, before you will be able to obtain our vertical and horizontal asymptotes, the first thing that we are going to do is we need to simplify the given rational function. So um, we have this original function here, y equals 5x squared plus 8x minus 4 all over x squared minus x minus 6. So the function given here may be rewritten by factoring the numerator, the expression in the numerator, and the expressions that you can find in the denominator. So factoring the expressions here, you will be able to obtain these factors for the numerator x plus 2 and the factor 5x minus 2, and for the denominator you have the factors x minus 3 and x plus 2. So once you are sure that you have already found all the possible factors of your numerator and your denominator's expression, you can simply cancel out all common factors. So in this case, we have the common factor x plus 2, so we can just simply cancel out these factors for both the numerator and the denominator. So now we have the simplified form of your rational function, which is y equals to 5x minus 2 all over x minus 3. Okay, so now we can now start calculating for your vertical and horizontal asymptotes. So first one, we will try to calculate for the vertical asymptote of your rational function. So a rational function has a vertical asymptote at the zeros of the denominator d of x of your simplified rational expression. From our given example, we have the simplified form now of your rational function given. So we have y equals to 5x minus 2 all over x minus 3. Now, to find the vertical asymptote, we need to find the roots or the zeros of your denominator by equating your denominator d of x equal to 0. So now we have x minus 3 as your d of x, and then we equate that to 0. So transposing negative 3 to the right side of the equation, so we will now be able to obtain x equals to positive 3. Now, we can say here that the vertical asymptote of our rational function is at line x equals to positive 3. So this is an example of a vertical asymptote at line x equals to 3. So you can see here, this part of the graph here tries to approach as near as possible with the vertical line at x equals to 3, and the side here as well of the curve, it tries to go nearer and nearer to the line, but they will never going to intersect with each other at any particular point. So they will just try to extend up to the positive infinity and here up to the negative infinity. Okay, now for the horizontal asymptote, you can find the horizontal asymptote by comparing the largest exponents or the degrees of your numerator and your denominator of the given expression. So take note that d sub n of x refers to the degree of your numerator, or the largest exponent or the highest value of exponent that you can find in your numerator. Now d sub d of x refers to the degree of your denominator or the largest value of exponent that you can find in the expression of your denominator. Now, let's say for example, we have this rational function here, 9 minus x squared all over x fourth, x to the fourth minus 2x minus 3. So we have the degree for your numerator d sub n of x is the value 2. So we can see here the one having the only variable here is this one, which is the biggest possible exponent's value or the largest exponent that you can find is the value 2. Now for the degree of your denominator, we have 4 because you can see here the highest value of exponent that you can find in the denominator is found in this term, x raised to 4. Now, the graph of a simplified rational function has one or no horizontal asymptote at all. So you can determine this by comparing the degrees of your numerator and your denominator. So we have these three categories here. So for the first one, when the degree of your numerator is less than the degree of your denominator, the graph of your rational function has the line y equals to 0 as your horizontal asymptote. Okay, so the second case is when the denominator's degree and the numerator's degree are both equal. So what happens here, the graph of your function has the line y equal to a sub n of x over b sub d of x, wherein these terms are the leading coefficients of your expression. So a refers to the leading coefficient, which is also the coefficient for the term that has the largest exponent in your numerator. And b is also the coefficient for the term that has the largest exponent in the expression of your denominator. So using this formula here, you can find your horizontal asymptote. Now, the third case, the last one, when the degree of your numerator is greater than the degree of your denominator, the graph of your function f of x has no horizontal asymptote. Okay, so going back to our example, wherein the simplified form of a rational function is given by y equals to 5x minus 2 all over x minus 3, the second condition is satisfied. So the second condition is given here when the degree of the numerator is equal to the degree of the denominator. So this is because we can see here the degree of the numerator is 1. You can see our x value here has an exponent 1 and our denominator also has a degree of 1, so which refers to this term here x. It follows that we can use this formula here y equals to a sub n of x over b sub d of x. So again, a is the coefficient of the term that has the largest exponent in your numerator's expression, which is here in this case we have 5. Now b again refers to the coefficient of the term with the highest or the largest value of exponent in your denominators. In this case here, we have the coefficient 1 paired with your x term. So you have 5 over 1, which is equal to 5. Thus, we can say here that the horizontal asymptote of our rational function is equal to the line y equals to 5.